and welcome to a new video about AR indoor navigation, this time completely based on web technologies, especially WebXR. Let's start with a short overview about the immersive web Github IO page, where a lot of WebXR examples are available and all the specifications are readable for you and everything else regarding WebXR. This is basically your first point of information when you want to get familiar with it. All the examples are purely JavaScript, so all the scripts and all the classes, all the modules you need are here, but to be honest, it is kind of complicated to get started with WebXR on the pure native JavaScript way, although there are a lot of examples and a lot of stuff for you to try. I personally would recommend using a framework like Three.js. I will use Three.js in this project, and I'm pretty sure every one of you knows Three.js. It is one of the most popular web 3D frameworks out there. And let's get started, I'd say, with the examples. If you're trying to look for WebXR examples, there are plenty of them, even with the source code and everything else. So basically, every use case is covered with the examples, and we'll go with the most simple one today, the AR cones sample. And first of all, let's try to install Three.js. So the documentation is pretty straightforward. You can use npm to install Three, a few samples, etc., nani, and you will not really get by without using some kind of bundling tool. As the most popular choice is Webpack, I decided to try something new today with Vite, the so-called next generation front-end tooling for bundling all of this WebXR application. And in the get starting session, we learn everything about Vite, how it's pronounced, where does the word come from, and so on. And the documentation is pretty good here. So when we're scrolling down, browser support, scaffolding, and here we go. Creating the first project with npm create Vite latest. So let's switch to Visual Studio Code, go to a parent folder and type in npm create Vite at latest, press enter, and wait for npm to do the magic. I'll just name the project test-vite to get everything set up, vanilla, JavaScript, and so on. And we see our project is here. Next step to do is to step into a project folder, npm install for installing every dependency, and wait for it a second to download and install. Here we go. And the next is npm run dev, because Vite already sets up a very, very small example. It runs at localhost, in my case 5173. And let's see, here is our sample page running with a counter button. You see everything is working with just setting up Vite and the template. Just scroll through the template real quick. There's a counter class which exports a setup counter method or module for usage in the main JavaScript. In the index HTML, it's just the app div and the script import for our main.js file. And in the main.js, everything is pretty straightforward. We're importing our style CSS, the image, our counter class, and the inner HTML of our page is also here, and the setup counter. The style CSS is also very basic. It comes with the template and can be modified, and that's basically everything. One cool feature of Vite is that it supports hot swapping. So if I change the string here from the logo and insert something new, you can see it instantly in your running page. So feel free to try it out. I'll switch to the project real quick. Just stop it here and so let's see how we can install something here. It's basically the same way as everywhere else where we're working with npm. So we're stopping the page, installing Three.js by npm install 3, press enter, wait for it to be downloaded and installed via npm, and here we go. So we'll just go on and check the 3 installation guide. After the install, the sample code is just import 3 from the 3 library and create a new scene. We'll just copy that here and paste that, replacing everything else that was here. As simple as that. And we console log the scene just to check if everything's working. Scene question mark and the scene variable just to check if everything's working. Saving, refreshing, F12 for the console. Oh, it's not running, so let's just start it up with npm run dev. And here we go, it's running, refreshing, and we see in the console log that our object is here. So 3 is set up, ready to use, and let's cancel that. And on the documentation page there are also there's all the process we did described, and there are some custom Vite commands. Just be sure when using the Vite commands that you use it the right way. With npx, some people who are not that familiar may just type Vite and run into this error that the term Vite is not recognized. So just using npx Vite, enter for basically run npm run dev, and there are other commands for building and for previewing, and we see that even after refreshing everything still works as the commands are the same, and these are just scripts for the npm scripts. So I guess the setting up everything, as you see, is pretty easy. I think we should move forward to the real project. So let's switch to the real project here. Let's do the code. Open the project folder. Give me a second. And here we go. As you see, there is already a lot of code in here, but don't worry, we'll go over it in a second. Just to show you that everything is based on Three.js, just have a look at the AR cone sample on the right lower corner. There's a white button which will take us to the source code. And I guess first have a look at the source code on the Three.js repo. Here is the import maps polyfill. We don't need that because of our bundling tool. Import 3, import AR button, create a few variables, init function for setting up Three.js, for setting up the scene, camera light, the WebGL renderer, AR button, some kind of geometry. We'll replace that later on. A onSelect method which will be triggered on touch, and the resize method, yes, it's pretty standard, pretty straightforward, and the animate function for rendering all our stuff, and the render function. So it's basically the same code. I'll just import the orbit controls too, so as long as we're not in the AR scene, we can still navigate. And a few of you might know the AR Foundation IndoorNavigation video tutorial on my YouTube channel. I just took the map out of this example and remade part of the AR navigation here. So here you see the map. It's basically a layout where I measured my room in meters and we will recreate them, or I already recreated it in Three.js with simple cubes, have this map as a floor, and make it possible to navigate through that. So let's have a look at the init function first. Here are the class, let's call them class variables. And the init function is basically the same as we saw in the repo before. It's a new perspective camera. I just position it a little bit farther away for the orbit controls. The renderer, make sure that XR enabled is true, the output encoding is right, and everything else. There's a hemisphere light, the orbit controls, which will look at the origin, and our AR button, and the renderer controller, the XR controller, sorry, and the select method for touchscreen events, placing a cube about 30 centimeters in front of the camera on touch, and set the rotation matrix based on the controller, and the render order. I'll come back to that later on. Here's the render function. We update our controls for enable damping or auto rotate, and the render function for scene in the camera, and the window resize function as it's done in the tutorial or in the example code on Github here at the AR cones. You see the button down here, Start AR. Sometimes when the settings for the AR WebXR simulator are not set right, this may say that your browser doesn't support AR. This is very easy to fix or to adjust. The drop down over here in the WebXR simulator, you may have to install it, by the way, is in my case set to Samsung Galaxy S8 Plus. If I set it to Oculus Quest, which is the default property, my browser says AR not supported, so make sure to switch here to the smartphone version, reload the page, and it says, well, you can start AR here and simulate it, which will actually look a little bit strange. It's a room, a skybox obviously, and a smartphone with a display which will mimic our camera display, and I can click on it and move it, click again, rotate it, click again, and the handle is gone. And with right click I can simulate touch interaction, only single touch at the moment as far as I know, and I can move the camera by pan and by rotating the view. And if I move my smartphone towards the rendered cone, we see that the cone is not within our camera view but within our smartphone view, so the smartphone behaves like it's actually an AR device tracking something. And when I frickle a little bit around, here you go, we can actually see the cone within our AR camera view, and we can also move it via the simulator itself. So there is the headset, which is basically our main camera view, and the right controller does nothing here because we're in AR, but the left controller is basically our smartphone, so clicking again for losing the handle and moving the left controller will also move our smartphone. And here we go. That's basically a very good way to simulate AR in the browser. The same goes for Chrome, Edge, and so on. For everyone who's not able to publish immediately and has just to think, just to test everything. The main difference to the example we saw before is the occluder material. So there is a property called colorWrite, and the property description is everything we need to know whether to render the material's color. This can be used in conjunction with a mesh render order property to create invisible objects that occlude other objects. So that's basically the main setting for our material, which will simulate walls in our environment. I recreated a new group and added the wall elements based on the floor plan in meters, so the position, the rotation, and their scaling. There's another method just for creating these wall elements and adding them to the group. Just as simple box geometries with a certain scale and a certain position. And the occluder mesh itself has the box geometry and the material, which is a standard material in green, but with the colorWrite property set to true in this case because it's the standard value. A new position set and the render order to 2. We'll go over that in a second. Everything added to the navigation area. Then setting the position to our starting position, creating a floor with a new plane, load the texture from our floor map, creating a basic material, the mesh, rotate it a certain amount so that it's basically really off floor, bring it down about 2 meters. You have to experiment on that and set the correct render order, add that to the navigation area, and finally add everything to the scene. And if we now test run everything after looking at the index.html, so there is nothing changed except the title, and there is a simple CSS for our body just to make sure everything is displayed correctly. The background color is black and there are no scroll bars because they don't look that good. It would basically work without the CSS styling too. Make sure that the WebGL renderer has its alpha setting to true. And let's see, I would say everything's fine now. We created the element and just give it a shot. And px vite, and let's see if everything builds. Yes, looks good. I have the IndoorNavigation Three.js as a subpage. And here we go, we see the green walls. We can move around with the orbit tools. We see a floor plan, the walls are there. Pretty good match for the plan, I gotta say. It's not the best detailed plan from the flat itself, but it will serve the purpose of prototyping here. And let's see, we'll start in the center of the living room. We set that down here at the navigation area group. And let's, I would say then, just make these walls invisible now and make sure that they occlude everything. So set the occluder material colorWrite to false. Refresh, and let's see, everything is black now, but don't be fooled. It's only black because the background of the whole thing is black. Usually if you have a skybox or something else, this would have the color or the picture or the image of the skybox or the camera image in our case, which is absolutely the way we want to occlude other objects in other rooms. Well, check the console, everything looks good, we have no errors here. Start the WebXR simulator, clicking here, and let's see, yes, it's the Galaxy S8. Start AR, and we see nothing at the moment, but when we rotate our smartphone for looking down, let's do that, because the colorWrite property is false. Maybe we'll just set it to true that I can show you the walls. So here again are the walls, WebXR is here, start AR button, and here are the walls. I guess that's a better introduction for that. So everything is basically here, the floor too. You see the caption of the living room, so we're basically in the center, a little bit off the center of the living room. And if I now set the colorWrite property to false, the walls are invisible, but they are still here. And if we just rotate to the floor, we see that our living room floor is here. And I'll speed up the video here just to show you that we are able to move towards the hallway and that there is something occluded. Just give me a second. Move it over here, here. And we see that slowly but steady the hallway will appear as I move the virtual smartphone. Okay, looking good. So I guess we are ready to test now. Let's see. Terminate the test page. And do we have something else? Yeah, well, I just put the links in here. Maybe I'll extend it with WebXR image tagging, which is basically in draft mode. Well, yes, we should talk about the transparent object occlusion, which is explained in this article on Stack Overflow pretty well. So you need the render order and the colorWrite property, and make sure that the object is rendered prior to the objects it must occlude. So mesh A with render order 0 here, we don't have a mesh A here, but we have a mesh B, which is basically the object we want to occlude. These are our cubes that we will spawn on touch on our screen. Render order 3, and the mesh C, which is the occluder itself. In our case, these are the walls of the room, and they have render order 2. So when looking at a project, Here we go. You'll see that here where we have the walls created, our render order is 2. These are the occluders, and the floor is render order 3, so it will be occluded by the walls, and every cube we create has render order 3 too, to be occluded by the walls. Now it's time to actually deploy our Vite template here, and there is a pretty good documentation for static deployment, building the app and deploy it on GitHub pages, for instance. I did that already, and I gotta say it went flawless. There were just a few things, but they were mainly on my side, so there is no fault on the Vite side, and I published this project to my GitHub page from the repo. The link is first of all in the video description and here in the source code, and you can just npm run build here for build it for the distribution in the dist folder, or again you can use the npx command, which can be found here in the getting started. Vite build, I guess, Vite build, yes, npx Vite build, just to show you that it's working. Here we go. Here is a distribution folder, sorry about that, and the deployment shell. Some people may run into the issue that on Windows you can't execute shell scripts without bash. The simple solution is to open the git bash from your git install. If you have it installed, just call sh deploy.sh. This is the very simple solution, or just install bash. So that's actually not a problem, just call it and everything should deploy according to the documentation. They have a pretty good deploy script here. I already did that. And just before testing, you can find it here on my page as well, but make sure to test properly because it's tied to my floor plan. The same goes for you, so if you want to use your own floor plan, you just have to change the walls and the cubes. And before you start testing, make sure the device and the browser you're on supports the WebXR device API. So on Firefox you have to enable a flag, on Safari you have to enable a flag, and on Chrome for Android and on Chrome and Edge it's basically supported. Here are the tooltips from the Can I Use website. Chrome for Android is the same, and Safari on iOS is not supported. So if you feel like testing that on iPhone, I gotta disappoint you. Write Apple an email so that they should finally implement their WebXR support on the Safari on iOS. And when you're on Chrome, for WebXR, especially for the image tracking, make sure to enable the flag for WebXR incubations. And I tested it on my Pixel 5 phone, so here you go. You see my GitHub pages website. I click on Start AR and you see my room, so it's basically working. By tapping on the screen, I'm placing cubes. Here is the floor plan. I'm more or less in the center of the room, and placing cubes all around just to backtrack my walk. So I'm walking over here, walking to the kitchen, placing cubes as long as I finally reach more or less the coffee machine. Here we go. And if I now turn around, you see that my cubes are still there and they are already occluded by the wall from the living room. So it's not perfectly accurate, but I would say that works in a way which will just need a little more of adjustment. And turn around here, moving into the living room, walking backwards, not trying to hurt me, and the cubes are occluded by the wall. That actually looks pretty good. And here they are when I walk around the corner. So thank you all for watching. That's basically a very good example for IndoorNavigation with WebXR. I'm thinking about turning this into a tutorial series, and please let me know in the comments if you're interested in that. Well, there are things missing like a minimap or let's say the navigation lines of navigation mesh. Drop me a comment, like this video, subscribe to my channel if you want to see more stuff like this, and I hope to see you soon in the next video. Bye.